Yes, I was talking to you about stability of alkenes on the basis of on the basis of hyperconjugation. We have learned earlier. After this, we have also learned what are carbocations, what are free radicals, what are carbanions. We have also learned bond fission. We'll continue this topic which we had stopped in middle. The stability of alkyl carbocations. But before I explain you what is stability of alkyl carbocations on the basis of hyperconjugation, let me take you back to the definition of hyperconjugation. See, we have done this definition of hyperconjugation. Structural requirement of hyperconjugation. We should have at least one sp2 hybrid carbon, either alkene, then comma, or an alkyl carbocation. Now we know what is alkyl carbocation. Or we need one alkyl free radical. Either of this. We need either of this. Are you following that? Right or not? We need either of this. And second thing we require alpha carbon with respect to sp2 carbon. Okay. Let us see this. We have learned about these parts. We have learned about stability of. Now I am talking about stability of carbocation. See, I have four kinds of carbocation. In this carbocation, this is positive charge carbon. It is directly associated with three more alkyl groups. That's why this carbocation is known as tertiary carbocation. Similarly, this carbocation is known as secondary carbocation. Correct or not? Okay. This is primary carbocation and methyl carbocation. Correct or not? You are aware about this, right? Now, here hyperconjugation will take place, and during hyperconjugation, one thing will happen. Since it has tertiary carbocation has 3 alpha carbon and each has 3 hydrogen, overall it has 9 alpha hydrogen. It has how many alpha hydrogen? 9 alpha hydrogen. So here 9 times resonance will take place. That's why this is most stable out of all this. It has 6 alpha hydrogen, it has 3 alpha hydrogen, and it has 0 alpha hydrogen. So this will be the least stable, then most stable, then most stable. It's on the basis. So carbocations, stability of carbocations rather say, is proportional to number of resonating structure or proportional to number of hydrogens. Okay, hydrogens, rather say alpha hydrogens. Okay, so in that case, number of alpha hydrogens are in increasing order. So stability is in increasing order. Remember, this is very important point. Tertiary carbocation are more stable than the secondary and is more stable than the primary. Tertiary is stable than secondary, secondary is stable than primary, and primary is stable than methylene. Remember this sequence. Is that understood? Any doubt over here? Correct? Similarly, we can explain the stability of free radicals. Same point. We have methylene free radical, primary free radical, secondary free radical, tertiary free radical. And since it has 9 alpha hydrogen, 9 structures, okay, 6 alpha hydrogens, 3 alpha hydrogens, 0 alpha hydrogens, stability, as we had seen earlier, tertiary free radicals. Tertiary free radicals are more stable than secondary free radicals. It's more stable than primary free radicals. Okay. In coming semesters, we are going to see certain reactions are faster and certain reactions are slower. Why? भाई टर्सरी फ्री रेडिकल जहां पे होगा वो रिएक्शन स्लो होगा क्योंकि वो स्टेबल है, वो इतना जल्दी रिएक्ट नहीं करेगा। जहां पे प्राइमरी फ्री रेडिकल हो रिएक्शन फास्ट है, अलग तरीके से सीखेंगे। बट उस टाइम पे मैं बोलूंगा आपको ऐसे, डू यू नो वी हैव लर्न इन सेमेस्टर 1 tertiary free radical is more stable than the secondary, then the primary, and then the methylene. That's why this reaction will take place in this direction. Is that understood? And every time it happens, let me tell you. Okay, I get more students in semester 2. They get new admissions. I don't know, this time batches are almost full. I might be, I'll not give any admission. If due to one or the other reshuffling takes place. And if I'll give new admission, okay, you'll find that new students when they come over here, I don't know how good they have learned this topic. And when I use this words, do you know semester 1 I taught you this? They become blind. And all 4 semesters will be blind. Because on this record, that's why I'm saying no. Please pay attention. Okay. For me, more than recording, you people are more important. Please pay attention. I'm teaching you very important things. The reason to record so I can give you anytime these things. These topics are very important. We are teaching you over here. Okay. Are you getting this? समझ में आ रहा है आपको? Continue करेंगे. So this was hyperconjugation. Bond fission we have already learned. We have already learned heterotic fission. We have learned carbocations. Okay. Now, actually, this topic also I left in middle. Topic was that alkyl carbocations, and we know what is alkyl carbocation. When a positive charge is present on alkyl carbon, carbon is known as alkyl carbocation. Stability of alkyl carbocation can be explained by two methods. One is hyperconjugation. Just now I had explained. Okay. Second method is I'm going to explain it. Inductive reactions. Because of two reasons, okay, tertiary carbocation is more stable in the secondary than primary. I'd already explained you hyperconjugation. Now, okay, I have already told you that alkyl group are always positive inductive group. What does my positive inductive group? They always donate electron. They always donate electron. See, I got here this tertiary carbocation. You can see that one carbon is contained with 3 more carbons, which is positively charged. Then I got secondary carbocation. Then I have primary carbocation, and then methylene carbocation. Then we have methylene carbocation. If there is a tertiary carbocation, okay, that means it is directly associated with 3 more alkyl groups. It is directly associated with how many? 3 more alkyl groups. And alkyl groups are basically positive inductive groups. Alkyl groups are normally positive inductive. So this alkyl is going to donate electron to positively charged carbon. Now, this carbon is already positive charged. And there are 3 alkyl groups which are supporting and they are donating electron to this carbon. If they donate electron which is negatively charged towards the positively charged carbon, obviously इसका positive charge nullify हो जाएगा. Positive charge will get nullified, and so the intensity of positive charge decreases. Intensity of positive charge decreases, and if intensity is less, it will be less reactive. If positive charge intensity is more, it will react with some other species faster. The reason intensity was decreasing because there were 3 alkyl groups were donating electrons. In secondary, how many are going to donate? 2. So here also intensity will decrease of this positive charge, but not as good as in the case of tertiary carbocation. It will be comparatively less. That means here positive charge is comparatively more than tertiary carbocation. Similarly, secondary has only one alkyl group which donates electron, and it has zero alkyl group which is going to donate electron. There is no one to donate electron. So it has highest positive charge out of all of them. That is the highest reactive. In that case, it is least stable. And out of all this, most stable is this. Understood? Earlier we had seen stability of carbocation on the basis of hyperconjugation. Now I am teaching you on the basis of inductive effect. Stability is proportional to positive power of group. If more positive power, more stable. That's why stability is like this. It's written also like this. Stability is in decreasing order because of more inductivity. Is that understood? Are you following me? Similarly, we have carbon ions. What do we have? Carbon ions. An ion of a carbon is known as carbon ion. As I already explained you, carbon ion carries 3 bonded pair of electrons and 1 non-bonding pair of electrons. That's why it has negative charge. That's why atom becomes negative charge. So carbon ion may be represented as follows. Correct? What are the characteristics of carbon ions? There are 8 electrons in the outermost orbit of carbon ionic carbon. It has 8 electrons. Okay, 6 electrons from the bonding pairs. Okay, 2 electrons from non-bonding. Hence, its octet is. It behaves as charge. It is a charged particle. It has negative charge. Nucleophile. Yes, nucleophile. I'll explain you what is nucleophile in last lecture. Which has attraction towards nucleus. It is diamagnetic in character. Okay, this is something which you are going to study in higher semesters. But let me explain that. Okay, first, yes, that's correct. Okay, it has all electrons paired. All diamagnetic substance, they have electrons in pair. Okay, in another way I can say, all the electrons in a diamagnetic structure, always they should be in the form of pairs. There should not be any electron which is unpaired. Is it correct? Yep. Are you getting what am I trying to explain? There should not be a single electron. It should be unpaired. That's the first part. Second part, it says diamagnetic. The meaning of that is when you put this substance in presence of magnetic field, it will be repelled by magnetic field. It will move away from magnetic field. It will move away from magnetic field. That is called diamagnetic. There is another nature that is called paramagnetic. Paramagnetic substance contains at least 1 electron unpaired. चाहे 10 पेड हो लेकिन एक अनपेड होगा तो भी पैरामेग्नेटिक. How many are paired? No issue. If it has 1 or more than 1 unpaired electron, it will show paramagnetism. It's opposite to diamagnetism. If you put it inside the magnetic field, under the influence of magnetic field, it will get attracted towards the magnetic field. Okay. So carbon ions, it has octet complete, 8 electron, charged nucleophile, diamagnetic, and it is formed, obviously, anion and cation are always formed hydrolytic fission. Okay. And it reacts with electrophiles. Obviously, वो खुद इलेक्ट्रोनेगेटिव है. खुद कैसा है? इलेक्ट्रोनेगेटिव है. अगर वो खुद इलेक्ट्रोनेगेटिव है, देन ऑब्वियसली उसकी ओर इलेक्ट्रॉन अट्रैक्ट करेंगे, सॉरी इलेक्ट्रोसेटिंग स्पीसीज अट्रैक्ट करेंगे। सी ये नेगेटिवली चार्ज, तो उसकी ओर जो भी सब्सटेंस अट्रैक्ट करेगा वो इलेक्ट्रोफाइल ही होगा, तो इलेक्ट्रॉन सेटिंग स्पीसीज होगा। करेक्ट ना? We know about electrophiles and nucleophiles. I told you in last lecture. Electrophiles are normally electron deficient species. Okay. Electrophile कौन है? जिनको इलेक्ट्रॉन की ओर अट्रैक्शन, वो कब हो सकता है? जब उसके पास लेस इलेक्ट्रॉन। Okay. They are also called electron acceptor or electrophile. Nucleophile, they are electron rich species or electron donating species. They are called nucleophile. Is that understood? Normally nucleophile negatively charged होंगे, जरूरी नहीं always negative charge होते हैं. Sometimes they are neutral also. Electrophiles can be of two types. Charged which are negatively charged रहेंगे, electrophiles are positive charged as well as neutral भी रहेंगे. Same way nucleophiles are negative charged, sometimes neutral भी रहेंगे. Okay.